Delta.
Perfect. Moving on.
So what's happening in delta, the reaction?
What's happening in delta?
Yeah.
2,4-D in pH.
All right.
Nitro group, and there are two groups, and then there is a phenyl group, and then there is amine 2,4-D in pH.
Okay.
By amine, I mean since there are two amines together, that is known as hydrogen, hence 2,4-dinitrophenyl hydrogen.
All right. It's either Charlie or Delta, right?
Right.
Delta.
Perfect. Remember the testing that we used to do for 2,4-D and pH does not require any temperature, and the results are really instant. So yeah, that's true. 23.
Delta.
Perfect. Move on.
Hydrolyze means we're gonna react it with water.
That is right. So which options are you stuck with?
We do nucleophilic substitution, right? First of all.
That is correct.
All right, just give me a minute, then I think I'm on to it now. Wait, so it can't be beta or Charlie, right?
Perfect.
Yeah, because it should be the same carbon atom. All
right. Now you got the point. Now move ahead. Now, among alpha and delta, your answer is based upon a very common sense based point, a very simple point.
Delta?
Correct. And why?
Because it's gonna make a ketone, like it's the double bond O is in between. It's not coming at the end.
Very good. Very good. One can't be true because ketones are never on terminal carbons. Good. Move on.
Yeah.
25.
Beta?
Good.
The same question, but this time they're asking for the positive reaction with tolerance reagent.
Let's skip it. Let's move on to 27.
Yeah, all right. So we're going to consider this as a primary alcohol.
Uh, yes, primary, because both alcoholic groups are attached to carbon atom, which is attached to a single carbon atom, not two. So yeah,
Yeah.
primary alcohol.
So in that case, two aldehydes only, and then they can be further oxidized to carboxylic acids.
So count the whole. Do you think these are 5 products?
These are 4 then.
Then think again. Actually, try to think out of the box.
Uh-huh. No, I don't get it.
Just a minute.
All right.
So you consider one of them gets oxidized and then the product would be aldehyde, the other one does
Yeah.
separate case aldehyde. Both of them are converted at the same time into aldehyde, or one aldehyde or one carboxylate or both carboxylates. If you count the possibilities, you will end up with the highest numbers, and hence D. And he said there are 5 possible oxidation products.
So one aldehyde, both aldehydes, that's one possibility. And both carboxylic acid is also another one. And
Both
then one
aldehyde is
aldehyde, one carboxylic.
right.
That's three possibilities.
One aldehyde, one carboxylic acid, both carboxylic acids, both aldehydes, and one aldehyde and one carboxylic acid. 5 possibilities.
All right.
And the total of 4 and 4. Because one's count is 1, so yeah, 4 and 4. 28.
Delta.
Good. Moving on, 29.
Delta again.
Can you tell me why?
We need a ketone. Alpha and beta are tertiary alcohols. They can't be oxidized. Charlie has a primary alcohol that will give aldehyde, and delta is a secondary alcohol which can give a ketone.
Perfect. 30.
Beta.
Good. And I've seen students falling for the trap of delta and considering Q to be the only product giving a positive reaction. Moving on with 31.
Can you solve this one?
Sure, not a problem. Okay, keep a couple of things in mind because this is going to really help you with MCQs like these. If there is any test with Toland reagent and that is coming out to be positive, remember Toland reagent is actually an oxidizing agent. It's an oxidizing
mild
agent
oxidizing
because
agent.
it reduces itself from Ag positive ions to Ag. So of course it's going to oxidize this one. So definitely that's the answer. But discussing other MCQs, this one works as an elimination reaction. This is converted back into an alkene. Now, I don't know whether we have discussed it before or not, but I hope you understand that alkenes can be converted into alcohols and alcohols can be converted into aldehydes and aldehydes can be converted into carboxylic acids. Acids can be completely oxidized towards carbon dioxide. This is the oxidation cycle. Every product that I've written over here goes towards right upon oxidation. And of course, if the cycle is reversed, it would be the reduction cycle. Not to forget, there are other chances from alcohols because alcohols can be converted into ketones, but the process stops right over there, right? So that is another step from the same cycle. But remember, if you're moving towards right, you are going for further oxidation. And if you're moving towards left, you are going for reduction. Remember, the highest charge that carbon can show is +4, which is usually shown in carbon dioxide. Hence, the most oxidized state. So that is a good way to remember which side we are going towards. Since this converts an alcohol into an alkene, reduction. This is definitely a reduction because a reducing agent is involved. And this one is also reduction. Why? Because in this case, we are converting an ester back into alcohol or carboxylic acid. Now, if I talk about ester being converted into an alcohol, the number of carbon atoms decrease. Esters have CO2 in their formula, while alcohols have just OH in their formula, which means esters are more oxidized forms than alcohol. So yeah, of course, it's again a reduction.
Yes, sir. All right, got it.
Are we good? So this covers almost all types of reactions that you have in front of you, making these kinds of MCQs easier. Okay.
All right, sir.
Let's move on. 32.
Beta.
Perfect. Moving on. 33. Would you find 33 easy?
I said alpha and 34 would be, I think, Charlie.
Oh, sorry, I didn't get that. You're done with 33 already. Very good. And 34 would be what?
I said Charlie, I think, yeah.
Charlie. How?
It can't be beta or delta. Because ethanol, it will distinguish by the reaction with Fillings reagent. And for aqueous iodine as well.
Again, I don't think you're doing it correctly. Maybe because you're not reading this one. It's cannot.
Okay, I'll try again. Beta.
Right, now you're good. Because beta is the only one which would come out positive for both of them. For the rest of them,
Yeah. I didn't
they
write
would
out.
be positive with one and negative with the other. Okay.
Yeah.
So 35. Come on, this should be too easy.
Yeah, just a minute.
And I don't know whether this hint is written in the book or not, but remember the hint that is mentioned at the start of this MCQ.
Delta.
Delta. Very good. 36. Do remember that Felling is the only, in fact, methanoic acid is the only carboxylic acid that comes out positive with Felling solution. None of the other carboxylic acids do.
Yes. Beta.
Perfect. Moving on.
Alpha.
Good. Next. Is this MCQ a part of your course?
Not sure.
I'm not sure either because ethanamides are part of A2 and this seems like an old paper.
Yeah, it is old.
The syllabus has been changed since 2015 like a couple of times, actually 3 times, 2016, 2019 and then 2021.
Or 23. Yeah.
Yeah, for 23, they made the changes a little bit earlier due to Corona. Okay, so let's skip that one. Though the answer to that one is D. Okay, the entire NH2 group is replaced, and since this is partial positive, this is partial negative, this is also partial negative because the structure is something like this, and this is an amide bond, hence the name ethanamide. Okay, this is partial positive, this is partial negative, this is partial negative, and there is excess of NaOH. It's divided something like plus and minus. So this gets to attack over here, replaces this whole thing. This keeps the bond, leaves out as NH3, and hence this one is converted into this structure. So hence this one is the answer.
All right. I was thinking about substitution in the nucleophilic one.
Good. That was the right direction to go for. 39. Remember, this is only about the observation and not about the products. Do not fall for the trap.
Yeah. Charlie?
Perfect. Because the bromine water and the oxidizing agents will all get decolorized or change colors. K2Cr2O7 doesn't exactly get decolorized. It's only C which is going to give a different one, because tolerance reagent
Yeah.
will give positive with CHO and not with CO. So moving on, 40.
Beta?
Well done. Moving on, 41. So did you get it?
Yeah. 1, 2, 3, 4. Just a minute, I'm almost done. I'm getting 8 functional groups of the ketone.
Didn't you just count 6? This one, this one, this one, this one, this one, and this one. Are you getting 8?
Yeah, but this one here, it has this one alkyl here, and this is also another alkyl chain. Like, it's continuing. So won't this give a ketone as well?
Wait a
And the same for
second.
here.
How many of these product molecules contain a ketone functional group? So it would break from here, 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 and here. So yeah, I'm right. Even when that's true, 1 molecule, 2, 3, 4, 5, and 6. Product molecules.
Yeah, but 2 ketones would be formed right here. And
that contain a ketone functional group. At least a ketone functional group. Make it more, contain more. He's not talking about the count of ketones. He's talking about the count of product molecules.
All right.
Right? If it were the count of ketones, yeah, it might have been different, not 6. Obviously more. I agree with that, but they're talking about the product. So try to see where the breakage is.
Got it.
42.
Beta.
That was very good. 43.
Beta.
Good. Why?
Aldehydes get reduced to primary alcohol, and the structure is like this: P double bond O, and then there's an H here. And so for it to be converted into a primary alcohol, we'll add one H here, underneath this carbon, and then H here, and the double bond will break. So two hydrogen atoms are added basically.
Two hydrogen added. Good. Perfect. Let's continue. 44.
Delta.
Well done. 45.
Charlie.
Good. 46.
Beta.
Good. 47.
Charlie.
Perfect. 48.
So this mechanism, I'm supposed to know this?
No, but you're supposed to answer with the help of common sense. You don't know the mechanism at all.
Right.
Let's suppose that you are supposed to just think about what's written and consider the possibility whether that would be true or false.
All right. Alpha?
Perfect. Now, as soon as you see the word nucleophilic in there, you quickly come to know say that C and D are incorrect. How come a proton or H positive can be a nucleophile, right? It's only A and B. That makes obvious sense that the nucleophile would try to attack something partially positive or completely positive. Why would it attack an oxygen atom, which is bound to carbon atom in carbonyl group? So alpha is the only option. Moving on.
Yes.
49.
Beta?
Perfect. Can you draw F and G structure for me?
Yeah, all right.
You don't need to draw the hydrogen atoms, just the main
I'll skip
skeleton.
those. Yeah. Over here. And then G is
Good.
yes, this is G. And then we'll do acidification. We'll remove
Good.
the OH from here and the H from here.
Right. Hence the COOCH3. Okay.
Yeah.
I guess that's it then.